We're going on now to topic 4 of chapter 1, exponential notation and scientific notation. We have a number of topics that we're going to cover: the product rule and quotient rule, zero exponents, negative integers as exponents, simplifying raising a power to a power, raising a product of a quotient to a power, scientific notation, and significant digits and rounding. Now, if you've had the class already, then you have a lot of background for this. If it's new, then we'll be going over some of the topics as we go on. But to start us off, we're going to go to the matching. Now, the key terms are to the right, and we want to match it up with these examples. So what I'm going to suggest, to keep the tape a little short, is you can pause the tape now, give it your shot, and then we will show you the answers. So as you look at these, here this is the quotient rule that we're going to subtract, and I'll go over that as we see another example. And this is the raising a quotient, which is a fraction, to a power. And this is the product rule, that when we are multiplying variables with exponents, if the bases are the same, we just add the exponents. And for number 4, raising a power to a power, where you can think of a 1 being there and a 1 being there, and you're multiplying. And here raising a quotient, let's see, in this case, raising a quotient to a power, that C didn't look very well. This is the power rule for number 5. So here we're multiplying the 5 times 2. That will give us a 10. Then we're going to add the variables. We will be adding the exponents on the variable. Here we're going to multiply, watching the signs carefully. A to the 2 plus 5 is 7. B to the 7 plus 4 is 11. And then since C is to the 0 power, and you may recall that anything to the 0 power is 1, we wouldn't write it. In example 8, here we're dealing with quotients, so we're going to subtract the smaller from the larger. We want to keep the letters positive, the exponents positive. So as we bring up the 4, as it crosses this division bar, it changes its sign and becomes a negative 4. So this then becomes t to the 6th. So here we're going to divide, watching the signs. 8 goes in the 40 5 times. X, bring up the 1, that becomes a 4. Y to the 2nd, and the z's cancel out. Now notice what would happen there. You'd have z to the 1 minus 1. As you bring the 1 up from there, that makes it c to the 0 power. And as we said, anything to the 0 power is 1. We don't write it. Now for these, we're going to evaluate where x is a -3. So we have -5, but anything to the 0 power, a -3 to the 0 power, anything to the 0 power is 1. So the answer then for this one is -5. Again, anything to the 0 power. If you put a -3 in there, doesn't make any difference. Because of the parentheses, anything to the 0 power is 1. Now here we're going to expand a -7 squared. So it's -7 times -7. This is going to be a positive 49. Now here you have to be very careful, because the only thing now to the second power is the base, which is 7. So as we square 7, we get 49. But now we apply the negative sign. So this is something you should put a star by. That this one, because the negative is included as part of the base, that's what you square. -7 times -7. Here you're just squaring the 7, then applying the negative. Now a negative exponent. So watch this carefully. This is a -7 to the -2 power. And in a sense, that's all over 1. Every number is over 1. But in order to do this, we can put that negative out here by the division bar. A 1 stays up in the numerator, but watch now what happens to this. I bring it down to our denominator, and the sign of the exponent changes. Again, crossing that division bar, going up or down, the sign of the exponent changes. So this then, for number 14, becomes a -1 over 49 as we square the 7. Now, this one, since the negative is included as part of the base, this becomes a 1 over -7 squared. Notice what's happening here. The 1 stays in the numerator. In a sense, that's this 1 that might be out there, which we don't write. But now we have to indicate there's something in the numerator. The -7 goes down to the denominator. The sign of the exponent changes. This now becomes 1 over 49. Because you're squaring a -7. Here they want you to write an equivalent expression without negative exponents, and if possible, simplify. So this is going to be 1 over 6 squared. As I move that negative exponent across the division bar, the sign of it changes. So this becomes 1 over 36. This now becomes, as I move that up over the division bar, 2 to the +5th, and 2 to the 5th is 32. And here we have the 4. Now the a to the -5 goes down below as a to the 5th, and the b to the 4th I'm sorry, b to the third stays up on top. So we've got all positive exponents, and there's nothing to simplify there. Now here we have x to the 8th. That's good. The 2 stays down below. The y to the negative 3 goes down. We just change the sign. And c to the 10th goes up. And that's the answer. You can't simplify, you can't cancel. There's nothing to cancel. Okay, write an equivalent expression with negative exponents now. So the 2 stays there. I bring the c term up, and it becomes the negative 5th. Again, bringing it across this division bar changes the sign of the exponent. This becomes 3x to the negative 8. Again, we don't do this often, but they're showing you how it works. All right, here they're asking us to simplify, write only in positive exponents. So here we have a 6 and a 1. That's going to give us x to the 7th minus 2. So this ends up being x to the 5th. So we are just adding the exponents. So here we go, 3 times 7 is 21. C, add up the exponents to the 20th. D, now we want positive exponents. Up in the top, it's going to become D. Negative 6 plus 2 is a negative 4, but we want positive exponents. So I'm going to take this and move it down, and that becomes d to the 4th. So this goes away. Let me erase that there. Okay. Now the next one down here, we're just going to move the negative 10 from the denominator, and this becomes then t to the 16th. As I move that negative 10 up, it becomes a positive 10 added to the 6. Now, as we do these next few, it tends to get a little complicated. So let's take a look at it and see if we can develop some strategy. Over here, for instance, we know the sign of this eventually will be a negative something, because there's a negative, and it's going to be, in a sense, a 1 over 4. Then we're going to manipulate the exponents so they all end up positive. All right, and we'll finish that in a moment. Here, now this is raising a power to a power. So we're going to multiply exponents here. So this is going to become 3 to the 2nd as we multiply the 1 that's by the 3 times 2. And this is going to be r. 4 times 2 is 8. This is s to the 3rd. And that becomes a 6. And the only change then is we simplify 3 to the 2nd. This will become a 9. And let me give you a chance to figure out what's going on here. Okay, I finished this top one up here. And let me show it to you. So we agreed that it would be negative 1/4. And then bringing the x to the negative 5 up, that became x to the 10th. And then y to the second we brought down, and this became just a plain y. And then we brought the z to the negative 8 up, it became a positive 8. Negative 5 and a positive 8 left me with a 3. Now, we could write it like this and include the 1, but often we don't include the 1. So that would be the answer. And for this one, again, I think we did this already. It's just 3 that will be squared is 9. R to the 8th, S to the 6th. Now this one we had to square the 5. That gave us a 25. And then we multiplied the negative 3 times 2. That gave us a negative 6. And I just wrote this out. Then we cubed the 2. We got an 8. 4 times 3 is 12. Then I'm factoring a little bit here. 4 goes into there once. 4 goes into the 8 twice. So far then, we have 25 over 2. You can't simplify that anymore. Now, in terms of the other letters, here we have y to the negative 6 and then a 5, which will leave me with y to the negative 1 up here that I'm going to bring down, and that adds to y to the 13th. And that's the answer. Okay, as we go on now, we'll see that we have, it gets a little complicated, but remember there's a little 1 right there. So that would be 3 to the 1st raised to the 4th power, so that's 3 to the 4th. A negative 2 times 4 is a negative 8. A negative 5 times 4 is a negative 20. And this becomes 3 to the 1st raised to the negative 5, so 3 to the negative 5th. A to the negative 20. B, now negative times negative makes us a positive 15. Then we group everything and we end up with 3 to the negative 1, A to the negative 28, and B to the negative 5th. And if you want to put it in positive exponents, remember that you have to put the 1 up there to occupy the numerator position. And this is in the denominator. Now, a little trick that I may have mentioned in class, whenever you see something in a fraction form raised to a negative exponent, you can make that negative exponent a positive exponent by taking the reciprocal of this. Now, the signs don't change. They stay exactly the same, but now that's a positive exponent. So it's going to be 3 to the 3rd, which is 27, 2 to the 3rd, which is 8, and then you're just multiplying. And then you're getting rid of the negative exponents by moving the negative 12 down. That becomes a to the 27th. The negative 3 up, that becomes b to the 6th. In class, we went over converting decimal notation and scientific notation. Here, this is scientific. We want to convert it to decimal notation. So we look at our number. There's our decimal, and it's 10 to the negative 6. So with our decimal being here, we need to move it to the left 6 places. That's what that -6 stands for. So there's one place, 2, 3, 4, 5, 6. And now I'm going to move the decimal over. It goes there, and I put an extra 0 to lock in where I'm moving the decimal to. So I'm moving it from here over 6 places to the left when that's negative. Now here, this is a positive, so I have this. Now I have to move the decimal place 7 places now to the right. So I have 3. I'm going to add 4 more zeros. And I'm going to move the decimal place over to there now. Here you don't have to add an extra 0, and you don't have to have that decimal place there. This is the number. We sometimes use commas to separate every 3. So this would be 80,340,000. Now when we convert from traditional standard form to scientific notation, we have to make this a number between 1 and 10. So I'm going to start here. There's my decimal. I move it over 3, 6, 9, 10. I move it over 3 places. 3.01 times 10. And I moved it over 10 places. And I now have a number between 1 and 10 times some power of 10. That is scientific notation. Again, I want to make this a number between 1 and 10. So it's going to end up right there. So it'll be 9.56. Now, how many places did I move it over? Well, 1, 2, 3, 4, 5, 6. So it's going to be times 10. But since this is to the right now, that becomes a -6. So converting this, I would start here, add 5 more places, 1, 2, 3, 4, 5, and put my dot. And here I'd start here, I have 2, I'd have to add 8 more zeros to get there. Okay? Now this last one is, we're going to look at significant digits. Now, how many significant digits does this term have? And the answer is 3. How many significant digits does this have? And the answer is 2. So, in order to do this, okay, in doing this, I multiply this by this, and I get that. But I have to look carefully at, here there are 3 significant digits, here there are 2 significant digits. So in my answer, I have to get the least number of significant digits. So I'm going to need 2. But I have here a 9, so I can round that off to, let's say, 14 times 10 to the negative 12. But that's not a number between 1 and 10. Decimals here, so I have to move the decimal over 1. In so doing, I have to add a positive power of 1 here. So my final answer then becomes 1.4 times 10 to the negative 11, because I'm adding one positive power there. Okay, on this last one, notice this has 3 significant digits. This has 2 significant digits. So when we do this division, we end up with this. But this number has 3 significant digits, so we have to go to 2. We don't have to round off. We would just drop this. But changing it from a number between 1 and 10, we move the decimal there. But now in adding it this way, moving it that way, we have to subtract 1 power of 10. So that's why we end up with 10 to the 20th. And this is our final answer. Okay? Again, when you have a small number and moving the decimal to the right, that adds a negative power of 10. So that's why we had to take 1 away from the 21 to make it 20. Okay, that winds up this lesson.